Alright, we are going to take what we call the inverse Laplace transform. So, because I'm doing differential equations, I am now learning about Laplace transforms. So I also do other kinds of differential equations, but Laplace transforms is just like an alternative method to solving differential equations. So yeah, that's pretty cool. And a Laplace transform is denoted by this curly L. It can also be written like that. It can also be written like that, or however you want to call it. And if you want to do the inverse Laplace transform, you just do -1, just like you do for arc sine. So yeah, let's get into it. So we're going to take the inverse Laplace transform of... Oh yeah, and by the way, when you take in Laplace transforms, instead of brackets like this, or parentheses, you use curly braces. So that's a change of pace, whatever. So we're going to take the inverse Laplace transform of 1 over s plus 1 times s plus 2. And by the way, Laplace transform is literally just an integral, well, an improper integral. So when you take the Laplace transform of f of t, it's equal to the improper integral from 0 to infinity of e to the minus st multiplied by f of t dt. I know that's really messy and it probably came off the page. Yeah, it's because I can't really put my hand on the page there. It's far away. Anyway, yeah, so that's what a Laplace transform is. So similar integral rules apply to the Laplace transform. So you'll see the rules being taken into place. For example, if I had like a 5 in here, I could pull it out the front of the Laplace transform, just like you wouldn't have an integral. If you had a constant coefficient, you could pull it in front of the integral, because it doesn't affect the final answer. So that's just a heads up. So how do we do this? Well, you can apply the same methods you do with integration. You can do Laplace transforms, or inverse Laplace transforms by partial fractions. So this can be rewritten as 1 equals a over s plus 1 plus b over s plus 2. And obviously that's still over s plus 1, s plus 2. I'm not really going to explain the whole method of partial fractions. Don't know what's... Doesn't matter. Alright, so 1 is equal to, therefore, a multiplied by s plus 2. And then that's plus b, s plus 1. So basically I just cross multiplied, right? So now we choose smart numbers to find out what our answer is. So s equals -2. It's not a smart number. You just look at this and go, oh, what's this going to make this equal 0? Well, -2 is. You could also set this equal to 0, but that's like the noob way of doing it. It's not even like seeing what's going on. So 1 is therefore equal to, because it's s is equal to -2, this is b is equal to -1. Because -2 plus 1 is -1, so b is equal to -1. And now we can find out what a is, so we let s equal -1. So 1 is equal to a, because -1 plus 2 is 1. So we have our values. So now the Laplace transform of 1 over s plus 1, s plus 2 can be rewritten as the inverse Laplace transform of 1 over s plus 1 minus the inverse Laplace transform of 1 over s plus 2. Alright, so the whole point of this is now we can actually evaluate this Laplace transform straight from a table. If you go online, there's Laplace transform tables, and you can see what the Laplace transform of something is and what it gets you. They're like little formulas, and you base your answer off what that table tells you. And the table says that, and this is how you solve your inverse Laplace transform. Someone not smarter than you and I has already done this. I think I've already said that. So if you've got 1 over the inverse Laplace transform of 1 over s minus a, you're going to get an answer that's e to the at. So because I've got a +1 here, let's just rewrite our, so the inverse Laplace transform 1 over s plus 1 will, if 1 over s minus a, so minus a number is going to give me a positive exponential, then I know that my exponential is going to be negative, but it's going to be negative a. So it's going to be e to the minus 1t, and that's minus the inverse Laplace transform of 1 over s plus 2. Again, we have a plus sign in between, which means that my exponential is going to be negative. So this is going to be minus e to the minus 2t. And that is the final answer. So this is a very, 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 very easy example. And you can get like the whole lot, all the tricks in one inverse Laplace transform. But I won't get to that yet. I'm going to do, I don't know how many examples, because you know, for me personally, to get good at inverse Laplace transforms is to do as many examples as I can, because the whole point of doing differential equations with Laplace transforms is because you need to do the inverse to get the answer to your differential equation at the end. So knowing how to do inverse Laplace transforms is key. So just a heads up. And also they're really fun. I love the symbol to curly L. I've always wanted to learn Laplace transforms, but I was told that it was like an electrical engineering concept, which it is, by the way. But me being a civil engineering student, I always wanted to know how to do them, and it turns out that at my uni, it's like electrical / mechatronics based, so it's sort of biased to what we learn. So I'm learning inverse and Laplace transforms and Fourier series and all that jazz. So it's actually really cool. Anyway, that's the end of the video.